Welcome to this conversation here at RISE, Computer Science and AI. My name is Martin Schörling, Senior Researcher here, and with me I have Saif Haridi, Professor at KTH, also a leader at RISE. And we are honored to have as a guest Jim Dowling, who's CEO of Hopsworks and Associate Professor at KTH.
Delighted to be here.
Welcome.
Thank you.
So we're going to talk about AI and big data, and of course, especially about Hopsworks. Why don't you kick us off, Saif?
Yeah, sure. Jim, nice to have you here.
I'm delighted to be here again.
Yeah, great. So, but can you tell us a little bit about the background for how did you start this company? Why did you start this company?
Yeah, it came from research. So we came from RISE and KTH, and we solved some hard problems related to building a scalable file system. You remember we won some awards. And this scalable file system, it had this scalable metadata layer. And we thought, this is a new capability. There's actually only 4 of these systems globally right now, I think. And we said, what can we do with it? And we decided we'll try and build a data science platform with new capabilities around this. And we kind of did that as research, and it was funded partly under your work and my work. And to keep that together, we started a company, because often when you build a software system and you want it to take on a life of its own, a company is a great way to help bring it out there. So in 2018, we raised some venture capital. There were 11 of us who left from here to start the company. And that's kind of how the genesis of it came about.
So if you look at Hopsworks now in the marketplace, what is your main offering? Can you describe the solution?
Yeah. I usually say it's a platform, a software platform for the development and operation of AI applications at scale with the industry's first and most advanced feature store for machine learning.
Can you explain what is a feature store?
That's a lot of those words, yeah.
Feature store. Feature store?
Yeah, I mean, the feature store is one of our unique offerings. So it differentiates us in the marketplace. So the feature store is a relatively recent system that's become widely adopted by basically every hyperscale AI company has a feature store to manage their data for AI. Because if you look at data that's used for analytics, like to understand how businesses work, to understand how sales are going, we have data warehouses, we have data lakes. But when you have AI applications that you want to use in production to make predictions, operationally about your business, to help you with marketing, to help you with understanding trends, that data that's used by the AI applications has to be available so that data scientists can use it, data engineers can feed that with data, machine learning engineers can work with it, and that we have a single place where you can understand what is the data that we use in our system for AI. And that's where the feature store for machine learning comes in. It's this data platform to train your models with and to serve your models with.
Yeah. Isn't it that in particular, I mean, that the feature store also has a role in the serving of the predictions? Can you talk more about that?
Yeah, that's a really interesting point, because when the way I described it was more as like a data warehouse. It's kind of a static place where we dump all this data. But in fact, I think the real key understanding of why it's an enabling platform is that it gives you live data to applications. So what does that mean? Real-time data that can come into your organization, you turn it into features, and now the applications and the models can get that data in real time. So what does that enable, right? So if you go back and think about the big breakthroughs in AI in recent times, in deep learning, so we have natural language processing. You type some text into Google Translate, it gives you back the text in English or Swedish. You put up an image in Facebook, it tags the people and tells you the name of the place. These types of applications, they have incredibly dense information in them. So text tells you a lot in it. You can translate it without any context. You don't need to know anything about the text, just translate it. The same with an image. You don't need to know too much about it to tag what's in there.
It's kind of a bulk data situation.
Well, it's more like the model that you trained to tag the people, or the model trained to translate the text, has all it needs. Yeah. You just put in an image, you put in some text, and you're ready to go. But in the enterprise now, we have stateless applications. They're trying to predict, what product to recommend. They're trying to help you, guide you through some sort of journey. They're trying to help you optimize your experience with the product. They need to know about your history. So what did you like recently? What have you looked at recently? I'm looking for fraud. How often have you used your credit card in the last hour? Is there a large amount of fraud activity in the current location? So we have these concepts that we'll call context, so what's going on right now, and then history, so what has happened in the past, that information isn't available in the little signal. You try to play with your credit card, you paid with your credit card, or you switched some money. That's just a small amount of information. We go to the feature store and we say, okay, tell me all the history about this user. Tell me about what's happening in context at the moment. And I pull all of this together. Suddenly I've got a very rich signal that I can make really great predictions with. So I would say the feature store at some level is kind of like working memory, if you will, for these AI applications, that the signal comes in, the user clicks on something, does something small, but we can go and reference the working memory to get a bigger signal, which we can make better predictions with.
So you're kind of creating the features in real time in production, actually.
Yeah, I mean, a key part of the feature store is that, so I should explain what a feature is to begin with, because it's always confusing
yeah.
to people who are new in the field. But a feature is just the piece of information, the compressed signal that we use to train models with, but also to serve models with. So if you're a database person, it's a column in a table. If you're a Python person, it's a column in a data frame. But that's what we're going to use to train the model with. And then when we want to make a prediction, we put in the same feature value in. Well, it's going to be a new one, whatever you're trying to predict, and the model will give you the prediction back. So when we use the term feature store, we assume, okay, it just stores the features, but like you said, Martin, we also need to compute them. We need to create these features. And the feature store helps with that. So there's libraries, there's APIs helping you to bring the data in real time, to compute things like aggregations or transformations on your data. So all those things kind of go into that ecosystem as well. Because it's really hard to put all these things together yourself. I think people understand that.
So Hopsworks, is it a feature store company or is it really a platform for AI? Can you explain a little bit?
That's a really great question. I mean, if you go to the website and have a look, you'll see we're heavily marketed as the feature store company, because that's our unique selling point in the machine learning space. And there are some other competitors that have come into the market recently. I mean, we released the first open source feature store for machine learning. We also released the first enterprise feature store for machine learning. So, we're taking a leadership role in the space, and we have the only conference on feature stores globally. We organized, had like 4,000 people last year. So it's a growing space, a growing new category. But I think, if you think about putting machine learning in production, that means building prediction services. So if a model were like an airplane, right, then it would fly. Okay. Well, what's a prediction service? Well, to me, it's more like it's an airport, right? It's the airlines. It's all of the services around it. It's the transportation infrastructure to get to the airport. So, maybe the Wright brothers flown an airplane from A to B, and that was great. But if you want to build a prediction service, just like if you want to have transport by the air, you need to have all this infrastructure around it. You need to have your airport, you need to have your airlines, you need to have the staffing, you need to have the transportation infrastructure. A lot of things need to be put in place so that transportation service over the air works efficiently. And it's the same with putting a machine learning model in production. It can make a prediction, you can train it on your laptop, great, but I want to get all the data from the enterprise together. I'm going to integrate it. Some of it will be batch data, so it's older data. Some of it will be live data. Some of it will need to be heavily computed before it gets there. But I need to make that all in place so that it can be fed to the machine learning model to make the prediction when you need it for your service. And then your service then needs to be made available for consumers, either as an operational service or maybe it's going to run on a schedule once per night. It'll tell you what the best songs are to when you wake up in the morning on Spotify.
I see. But when you talk to your customers, you only say, I am a feature store company, or I'm going to provide you a complete platform to develop your application in?
Yeah, so
different customers, I guess?
We're identified as the company who provide that part because that's our USP, but you're correct. We do actually do the whole end-to-end thing. And, people who want to put machine learning in production today do need all of the services. So you do need a feature store, probably. You also need somewhere to train your models. And if you're using deep learning, you might need even GPUs to do that. To serve your models, you need some infrastructure to host them if they're going to run 24/7. If they're going to be batch, you'll need some orchestration infrastructure to make sure those batch services run on a schedule. Hopsworks provides all these capabilities, but if I'm to be honest, most of the people who come to us because they need a feature store. They have invested already in AI. They have data scientists who are training models on some platform that they've already invested in. Maybe they've already started serving some models, but they haven't really gotten it in production. They need a feature store to tie the bits together, tie the data to the model, and often we come in. So we work with really large companies at the moment, but we also have some companies that do everything. So in Sweden here we have Arbetsförmedlingen, who are the National Employment Agency, and they train models, they serve models, they use the feature store, all of that to help bring candidates who are searching for work together with employers who are offering work. And that's the kind of prediction service that really helps companies add value to the products they're offering and the services they're offering.
But when I looked at your site, webpage, you have also another product called RunDB. What is that?
Yeah. Okay. Now we're digging in. So let me take a step back. Okay. So what is Hopsworks? So take a little step back. So Hopsworks is a number of things, right? It's a software platform, and we built it from the ground up when we started here. We started at the data layer. Most people start at a very high level and say we'll use these cloud services, pull something together, and sell it. We actually started at the bottom. We built a data platform, this file system, and we built it on this open source database, which was called MySQL Cluster, which now we call RunDB. So the inventor of it, Mikael Ronström, is from Stockholm. He worked previously at Ericsson, probably a colleague of you, Martin, at some stage. He then went to MySQL, who are now Oracle, and it's open source. So it was core to everything we do, RunDB. It's the world's fastest key value store with a SQL API. It's incredible technology. It's been difficult to kind of set up, install, and consume. So we are turning it into a cloud native database. And we're making it easy for people to use this incredible technology developed here in Stockholm. And Mikael has been working with us, and he's leading that initiative in the company. So we build the entire platform from the data management from our file system, plus this high availability, low latency serving layer. And those two layers actually together are what make up the feature store, because the scalable storage layer, the file system, that gives you your data for training. And you'll need a lot of historical values of your features for training.
So you mean that RunDB is also an integral part of the feature store?
Oh, of course, because it's yeah. So if I have a model that's running in production, and that model needs access to features, and I'll give you an example. Okay, if I want to do live recommendations of songs, and there's a certain company in Stockholm who do this, right? Spotify. So we did some work with them, and they're looking at doing live recommendations with a new architecture, recommender architecture called a two-tower recommendation system. So you have deep learning embeddings, but the essence of it is that you go to this very large embeddings database and you get back recommendations, maybe 200. But all you're getting back is minimal information about the songs. So you say, okay, here's the identity of the song. Now we need to order these 250 songs together. You need to go to RunDB, this feature store, to get the features for those songs, because you want to order them with respect to the user. The user has certain preferences and history. We talked about before, there's history. There's also context, what's popular right now. And we're going to munge those together along with the features of the songs. What's their genre? Who wrote them? Have I listened to them before? All that information will come into play when we put it all together. But I need to get 250 rows back from my database, and I need to do it in 28 milliseconds. And that's what RunDB enables.
Okay.
So this is, and because if I go to a music application, I want to search for a song, get a recommendation, it's no use arriving in 2 seconds or 3 seconds. People need it in sub 100 milliseconds so that they don't experience any sort of delay. So in particular, as a platform, we're very much in the high performance space, the really highest performance, most challenging machine learning production systems that need huge amounts of data with very low latency, and RunDB is the platform that enables that for us. So you can do things like online recommendation systems with this two-tower recommendation model, get back hundreds of candidates, score them all with the feature store and the ranking model, and then present them to the user. So if I'm a user just searching for your song, you think there's not much happening, but really there's hundreds of database queries going on in the background, hundreds of models being scored and results being returned to you, and you just think, oh, it was a lookup, but it wasn't. There was a lot of infrastructure behind that.
Can I shift a little bit? I think you touched on it, like the delivery model towards the customer. I mean, maybe you started out as an on-prem software solution, but now, of course, you are a managed service on the cloud, and there is, either you use the customer's cloud accounts or you have your own cloud accounts and sort of bundle that. What are the major kind of evolutions in that space?
That's a huge. So back to your point, we did build a whole platform. So when you build a whole platform, you can sell it as an on-premise platform in any customer's data center. And that's kind of how we started out. But once we raised our first piece of money, I think at our first board meeting, I said, we're building a cloud native platform. And they're like, can we not just sell it first? But the thing is that a paradigm shift is happening in how we deliver software. The cloud is changing everything. And most people don't really want to run infrastructure. They don't want to have to manage and install and configure a feature store. If they can go to the cloud and press some buttons and then the feature store is running and they can access it, then they're happy. So at least happier. Hopefully they can be more productive. So there's different ways of delivering software in the cloud. You have, software as a service is the term we often use, that you get your feature store, it's running for you. But large enterprises are happy enough with that, but they kind of want the data to be in their account. They don't want it to be running in your account. At least very large companies are like that. So that's the delivery model we have for our SaaS offering, that the whole Hopsworks platform will be installed in your account and we'll manage it in your account. And all the data will stay there and none of it will leave your account. Now, the trade-off there is that, now you have to have an account, you have to set it up and configure it so that we can deploy that. There's something called a cross-account role in AWS, for example, you need to configure. And your average person doesn't really want to do that, So the fully managed, where all of the data is managed by us on behalf of customers, that's something that's coming on our journey, I guess, at some point.
Is that the next step in that?
I mean, I think it's a logical next step for companies. But, from a business perspective, it makes it easier for people to onboard them and consume the platform. But on the other hand, there's business risks associated with managing people's data. I think it's for the larger kind of cohort of people who want to just get started with feature stores. That's what they really need. Whereas large enterprises who are investing heavily in AI now, they prefer this hybrid model where everything runs in their account and they manage it themselves. I mean, you see it with GitHub. If you take GitHub, most developers use just normal GitHub, but large companies will have GitHub Enterprise. And I think that's kind of
And they have their own, you mean hardware or
no,
they use the cloud?
They use the cloud, of course, and it is, infrastructure gets created in the cloud. So to explain just how it works, that you go to hopsworks.ai and you do have to configure your cloud account to allow our platform to start the cluster in your account. But once you've done that, then you can just say, okay, I would like a cluster. It can be this big, and it'll get provisioned in your account, and it will use the S3 bucket to store the data. And if you want to expand it, make it bigger or make it smaller, if you want to stop it, start it, you want to create backups of that, you can do all these things. You can upgrade it. All these kind of administrative things that would normally be a lot of work, and you might employ someone to kind of manage that platform for you, now become accessible to ordinary developers. So that's the basic idea,
If we go more to more general questions,
yeah.
So what do you think the status of AI in Sweden?
AI in Sweden. I mean, we're a Swedish company, and we're based in AI in Sweden. So obviously, there's things are happening here that are quite interesting. I mean, I think we started a bit further back when the new wave happened, and I came from Ireland, from Trinity College Dublin, and we had a department in computer science, and we had research groups in AI. And when I came to KTH, we didn't have, there is one group in research in AI, but in Sweden in general, we don't have as many. I think other countries were ahead when the new wave kicked off. I think we've caught up quite a bit. I taught the first course in deep learning in Sweden. It was a master's course, and I think it was 2017. I thought it was very late. Giving that, because I knew in other countries that they'd already gone ahead. So I think we're a little bit late to start, but we've had a lot of initiatives in recent year. The Vandenberg Familien with the WASP initiative has been great for research because it's really helped strengthen the research base here. But then on the industry side, I think Europe in general has been behind, right? If I'm to be brutally honest. A lot of people will look at the top publications accepted at conferences like Neural PS and ICML, and they'll say, well, look, there's a lot of Chinese at the top. But in terms of industry, I don't, you see a lot of Chinese companies using AI successfully. So, you've got TikTok, and TikTok is really about real-time AI, all about real-time AI. As you're scrolling, and it's really updating its preferences as you use it, and that's been one of its key advantages over YouTube. And of course, then, the American cloud giants are leading a lot of the way here. So there aren't that many companies in Europe who have a similar profile to us. In Stockholm, we have a bunch who work in the data space, and there's Peltarian who do kind of making AI easy to consume and to develop. But like globally in Europe, we don't have the really big unicorns that you're seeing in the States in the AI space.
What can be done more on the European level, you think, too?
I think we have some structural weaknesses in terms of data, because AI is fundamentally linked to data. Now there's one company, Data IQ from France. I think they do development, a platform for developing AI applications and operating. But they don't have a data layer, right? And we don't have cloud. We don't have a European cloud to converge and coalesce around. That's been a structural problem that I think really will help.
Problem, yes.
I think it's a huge problem, yeah. And
there has been a lot of discussion around like public investment versus venture cap and those.
I mean, something has to happen, right?
Yeah.
Like, I mean, the thing you can say about Europe is that the large corporates have not stood up, right? None of them have come up and put their foot down and said, we're going to build the European cloud. And that's kind of disappointing. Yes. So then the question is, does the government jump in and say, we'll do it? There's been some initiatives that have been not very well executed, in my opinion.
I mean, arguably there are French cloud providers and German and Swedish, but it's fragmented.
So. Oh, extremely fragmented, yeah.
Very small.
And I think people know, developers know that that's the Openstack cloud.
Yeah.
No one wants to go to the Openstack cloud, really, you'd have to start over and say, okay, we're going to build the Kubernetes native cloud, Cloud V2, and then we go from there.
So again, just for the audience, what is OpenStack Cloud?
OpenStack is an open source platform for virtualized compute infrastructure. So you can virtualize compute, CPUs, RAM, storage, and you can say, give me these resources, which in effect ends up being virtual machines.
When you say it is just OpenStack Cloud, you mean you imply that it is inferior, say, to Azure or Google or Amazon.
I think that's pretty well accepted amongst developers as a user experience.
So that is a problem then if you try to start a company based.
Of course, it's a huge challenge. I
think in fairness, we should say that the European providers also have Kubernetes.
Oh, they do,
nowadays.
Of course. No, look, I think a lot of them are doing really good work, and I know there's quite a large French cloud. I can't remember the name of them off the top of my head, but they're doing quite well. And in Sweden, we have a couple as well that are quite okay. City Network. But it's really hard. Like, if you just look at the sums involved, I think it's tens of billions of capital expenditure by just Google, by just AWS, by just Microsoft per year. We're not even. I mean, if we invest 100 million euros in a German-French cloud, that's just a drop in the ocean compared to what they're investing. But I think in AI in general, like you can start at the top and say, okay, I'm going to solve a niche problem, and I'll build on all the cloud infrastructure, and I'll kind of take that out there. But it's almost like saying, okay, I'm going to design a new chassis for a car, and I'll just sell the chassis. Okay, we'll let someone else build the engines. We'll let them build everything else. And if you don't build the engine, if you don't build, then eventually someone else will build a better chassis, and you'll make your day in the sunshine, and it'll go great. But whoever's building the engines will keep changing the rules for how the car should be shaped, and then you need to adapt to it.
This was very clear already from operating systems for computers and so on. That's why I feel like there's no. I mean, in a sense, there is no European computer companies because they don't.
Well, I think you have a little bias here. This is what we talk about are system software, right? So if you move in the stack, we've been talking about lower down in the stack. So operating systems being at the bottom, they're on top of the compute infrastructure. We made a big mistake with Symbian. Symbian could have been the European operating system to lead to domination of the mobile industry, but it wasn't, because we did a bad job. And Apple did a better job, and you have to be honest about it. And that failure in system software is reflected, I think, in a lot. So companies like us, who are a system software company, pushing out the state of the art globally, it's challenging. It's challenging because the venture capitalists don't have experience in funding us, and they treat us like other companies. And a lot of the European companies who have been successful in this space, companies like Elasticsearch or Elastic, they went straight to America. We've had other ones JBoss, I think, from France. You know, there's other ones like Colibra in Belgium. They all went straight to the States because they understand that this engine building companies who build the system platform companies really can shape new categories, and you know, they get more financing. I think, you know, that's the other reason.
I think we came to this interesting question. What is your personal opinion about starting a company in Sweden or Europe compared to starting it in the US?
Yeah,
you have some experience, I guess.
I'm Anglo-Saxon, right? So you know, I have an Anglo-Saxon perspective on the world as well as a Swedish perspective on the world, and you know, I've had students start billion-dollar companies from Ireland who are now in the States, Intercom, for example, and you know, you can say that I think talent-wise, absolutely, we're on a par or better even. You know, the technical universities in Europe are at least as good as the top tier universities, and that's the engine for any startup is talent. So that is the foundation. I think we have that. Definitely here in KTH we have it, and RISE, and we have great programs like the European Institute of Technology program, which brings brilliant students together at both master's and doctoral levels. So that we've got definitely right. I think, you know, starting a company, we managed to get VC funding because we had a customer on the hook. So it didn't matter that we built the world's, you know, fastest hierarchical distributed file system, that we had this, you know, great new data science platform. We couldn't even get seed funding until we showed we had a customer. That's hard. It's hard for a startup to get that far if you're doing deep tech. I think in the States we would have got like 10x the initial funding round if we came out of Berkeley, or probably more than 10x. So I think, you know, that's the funding gap is still a gap. I think it's improved a little bit, but it's still a large gap.
And this is not only in Sweden, but in Europe.
I think in Europe in general. We don't have the VCs don't have the experience of enterprise software companies because most of them are coming from the States still. So the systems platform companies. You know, we're great at consumer tech. You know, we've been very successful in kind of, you know, quirky areas like scooters, electronic scooters, or you know, but I think a lot of the platform software companies, we can see it today, the Googles, the Facebooks, the LinkedIns, the, you know, Microsofts and so on.
Yeah, if we zoom out a bit, if you look at the total industry and the trends, and what do you see there? I mean, everyone is talking about GPUs and new hardware, and there might be new, you know, HPC maybe some people talk about, and maybe even quantum technologies. I mean, what's your view on the bigger roadmap?
Yeah, I think the trend has been clear for a number of years, and I mean, I gave talks 3 or 4 years ago showing the growth, and I'm not the only one, obviously, the growth in the size of models and the growth in the size of data sets. And we've seen, even up to today, we're seeing it on a weekly basis, we're seeing new improvements in NLP and computer vision by using larger data sets and more compute and larger models. So that trend has been inexorable. So how do you enable that trend? Well, obviously better GPUs, better compute, better storage, better networking. So I think that trend will continue for quite some time. It's pretty inevitable. But if you think about the kind of problems they're solving, right? We're solving natural language processing. So, you know, maybe we're going to generate some new text for you. Great. And this is what we talked about earlier, which is that, you know, in these kind of models, you put in some text, you get out some text. It needs no context, no history. The same with image recognition. You know, you're building a self-driving car based only on images, nothing else, just on computer images. So all the signal is in the images that are coming in. I think the next trend is real-time AI. I really do think that real-time AI means that if you're going to learn AI, you're not going to just go to this MNIST static data set, which has a number of images. You're going to train the model and give it another static set of images, and it'll tell you, oh, this is the number 2, this is the number 3. So that's not a service, a prediction service that will change the world, right? A prediction service that will change the world will tell you right now, oh, you know, it looks like the queues for the lunch restaurant will be a bit lower in about 15 minutes based on sensors in the building, the current weather, and you know, the time of day and the time of year. All those features that will help make that prediction, some of them will be kind of well known, such as the time of day and time of year, but some of them will require really fresh data. I need to know like how many people are roughly in Science Tower right now, or
does
in
that mean
Electron.
that it's not necessarily about the large scale then? Then it's maybe more actually about the smaller scale and the distributed
geographically maybe focused.
Well, I think it's about data flows, right? It's about
But Jim, when you talk about it reminds me also what Uber is trying to do nowadays, huh? Where you try to match drivers and restaurant.
Absolutely, and that's what they do. But they do it with real-time data. So,
exactly.
But they solve specific problems related to transportation. So how do you transport people? How do you transport food, and so on? So, and in fact, their feature store had this domain-specific language, just for these particular types of problems.
I see.
So we built a more general purpose feature store based on data frames that would help solve more general purpose prediction problems, not just, let's say, transportation problems. So the challenge here, right, is that how do you get all the data in? So it's going to be live data coming from sensors, from, even in Sweden, we look at things like the electricity price, right? You can get that currently live. You can get the weather forecast. You could predict, your cost of your personal electricity bill if we could just merge and pull those data sources together. So I think, the big trend of digitalization, where we are leading in Europe compared to the States by a long, long way, if we can pull those data sources together and create kind of markets for real-time data and then make that data usable by machine learning models, we can build really, really amazing operational machine learning models that help us in our everyday, help us to solve small tasks, planning, and make our lives better. And I think that's something that we're really trying to do as a company, is trying to build that infrastructure that enables the flow of data to your models so that they can use context, they can use history, and make better predictions, and really make AI more human and change society.
This is really like the vision now of Hopsworks.
Well, I mean, I think it's my vision of how I see that we can make an impact in this space. I think real time, we've talked about a lot for a long time in data. It's been considered a very challenging technical problem. People often think about it as, I need to handle petabytes of data at scale because that's what Uber do. But I think there's ordinary developers who would love to do more than just train a model to predict a number based on a static data set. They'd love to get their hands dirty on real data coming in the world and build real prediction problems. And that's something that we're really focused on helping them achieve those dreams.
It's a great vision. It's more about orchestrating data flows and kind of solving
maybe in the
a
context
bigger
also.
problem rather than just to have like data storage.
And feature engineering is very much something that I think people who are new to AI don't know that much about. You can do a course from Andrew Ng or from Fast AI, and the data set it's like a ready-made dinner, right?
Yeah.
It's you're great at eating the dinner, but how do you cook it? How do you prepare the ingredients, So taking data that comes from a sensor, or taking data that comes from let's say the electricity price, which is available by a REST API, how do you get that in to your model? How do you use that data to create training data to train a model? These are skills that are going to be really paramount to building these next generation prediction services.
Some of what you're talking about can be called ML ops as well.
Oh,
I mean, like that's of course a buzzword in the industry, and so I guess part of what you're talking about is actually an ML ops kind of system.
What's ML ops?
What is
what's
ML ops?
ML ops?
Everyone wants to know. I mean, for me, ML ops is it's a methodology with some tooling around it. So think of it as being going from putting together cars to then the first Ford factory that had a conveyor belt that did it in a systematic, structured way. So what you have is we're trying to build software in a systematic, structured way by automating everything. So that means automating the building of the software, the testing of the software, the deployment of the software. So automation is key. Testing is also key. So if you're going to create a feature, well, you'd like to test it, make sure it's okay, and somebody has changed it. Is that okay? Are the downstream models dependent on that feature? Are they going to break? I train a model. Does that model have bias? Can I test it? So the feature store can help you create different, what I call evaluation sets, to make sure that the model isn't biased against, people with this dialect or that dialect. If we're, we had a particular problem related to, audio files and people with different dialects in Sweden. So you don't want them to be biased against someone with a particular dialect. So, I think ML ops as a paradigm, we have the automation, we have then the testing, and then finally versioning. Because when you create something new, you need to version it, and that means sometimes it might mean that you have the features go into a model, we have a schema for those, and we change that and we break it. Maybe the data going in comes in chunks. Maybe we update it once an hour. So we need to kind of go, whoa, that data that went in was bad. Let's pull it out. So if you can make these kind of operational aspects or development aspects as easy as possible, you kind of create the modern kind of factory that can kind of help you go from data and some code to a model as the output that really will solve this prediction problem. And then you need the infrastructure around that as well to enable the new data to flow in to make your predictions. So I think it's really just a word, MLOps, for kind of all the infrastructure you need around your model to make it productive and usable.
But obviously, maybe a customer has a whole ecosystem of solutions, and you may want to solve some particular part of that. Or can you talk more about that?
Yeah, I think that's really where we are. So if you think about software development, we always have ecosystems, so Kubernetes is one ecosystem, and then you've got the managed cloud offerings, AWS and Google and Azure, and MLOps is just like that. So you have a number of different competing solutions. So if you go back a year ago, people thought, oh, there's something called Kubeflow by Kubernetes that Google developed, and you thought, I'm going to bet on that. And then Google stopped developing it. They just said, oh, we're not going to develop that anymore. And they went to their own managed platform called Vertex that they released in the middle of last year. So if you're a customer trying to pick, it's really hard because you have ecosystems. I mean, we have Hopsworks. You can do it all in our platform, but we're also what we call best of breed, that you can say, I'll get this nice data warehouse and I'll put it together with this feature store and this training platform and this serving platform. Now, we do training, serving, and feature store, but and there's some companies who try and say, we do the whole ecosystem. So if you're Databricks, they'll say, well, put your data in Databricks and we'll do it all. Google will say, put your data in BigQuery and we'll do it all. And AWS will say, put your data in Redshift and SageMaker will do it all. So I think, it's going to be interesting to see how this plays out. There will, I think if you go back 5 years ago and you looked at data warehousing in the cloud, people said, well, obviously BigQuery will win and Redshift will win and then Azure Synapse will win because they're the cloud native data warehouses developed by the cloud providers. But they didn't. It's been Snowflake and Databricks have been the big winners because people wanted some independence from the cloud vendors. So we're hoping that will, history will repeat itself somewhere there, that we're positioned as a cloud independent vendor. Whether it's going to be best of breed or kind of end-to-end machine learning platforms, I think it's still to be seen, There's a lot of innovation happening. So if you want the best feature store, you've got to go to a best of breed person right now. But if you want something that's just good enough,
there is still a lot of space above the cloud providers.
There's a lot of debate right now about where do software vendors fit in when the cloud providers themselves move in and provide software. So if you're a big company like Oracle or IBM DB2, they've been very successful data warehouses and databases, and the cloud vendors are selling their native versions. How do you compete in that environment? And I think anybody who's developing enterprise software on the cloud is thinking the same thing. When will Amazon come in and have a competing platform in my space? And that happened to us, right? So, we released the first feature store for machine learning, and then a year ago, Amazon released the SageMaker feature store, and then it was followed by Databricks, and then followed by Google Vertex. So, we're familiar with this, and you have to compete on obviously having better performance, better usability, better integrations, and many companies, aren't okay with having all of their data in, let's say, BigQuery, or all of their data in Databricks or SageMaker. And then a company like us can come in and be flexible enough to help them, when their data is located on many different services. So I think that, it'll be interesting to see how this thing plays out. I don't make any predictions.
But another question coming also from the customer perspective now. This is a bit different topic, but I think what we've seen during the last years is you have data scientists, and then you have domain experts or the domain specialists, and the data scientists are supposed to help the domain specialists with using these tools. Are you seeing a shift there, that the domain specialists maybe are using the tools themselves more, or sort of which puts requirements on usability
Yes.
and other things. So
Of
do you
course.
see some evolution there?
I mean, there's a lot of things happening. You may have heard of AutoML as a space where you can get domain experts to train models. And I honestly, my take on it is that you have to bring the people who own the data. It's actually the data engineers who own the data. They manage the data warehouses and data lakes. You bring them together with the data scientists and the domain experts, and also the operations people, machine learning engineers who put the models in productions. That's kind of where we come in and we see the feature store. It's a collaboration platform. It's a platform where they can all meet and do their stuff on the same platform. Now, if you talk about getting a domain expert in, who maybe they know SQL or they do business intelligence and they can generate some reports, can they train a model? And this is really an open question, I would say, right now. There are very big companies who've raised a lot of money, like DataRobot, DataIQ, H2O, and they have this AutoML vision that you do not need to be a machine learning expert to train a model. And probably they're correct for some use cases. Probably they're less correct for other ones. So I think probably if you take a service that's going to be key to your business, a revenue driver, maybe it's built on a lot of data scientists will take those, right? Because they'll need to be optimized, they'll need to work with data, there'll be customizations. Maybe for some specific use cases, maybe you work in marketing and your data's coming from HubSpot and it's being put into your data warehouse. You can pull that data and just press some buttons and it'll make some predictions for you, and maybe that's good enough for you. So I don't make any predictions. The only thing I can say is, if you show me the money, where's your money going? We have some work in AutoML. We have a framework called Maggie, but Maggie is specifically for data scientists to help them use compute resources to do hyperparameter tuning at scale with many CPUs or GPUs, and also to train models faster. So distributed training or model parallel training. But being able to click a button to say, I'll find features for you and I'll train the model and use the correct model architecture, that's a really hard problem.
I mean, you are experienced now in this market. You see a lot of customers in different domains, in AI customers. But wouldn't you see that the future will be depending on which application domain? There will be specific model for these models, for example, I don't know, in pharmaceutical, agriculture, whatever, huh?
Yes.
Betting. So there will be some kind of a new strata of companies, maybe just specialized in these things. Or what do you think?
You may be correct. It's a really open question, I think. If you think about data, right now we have data warehouses and they provide the data for all of these different verticals.
Exactly.
And they manage the data. And what you'll have on top of them typically is a layer where the domain experts will use a business intelligence tool, maybe like Tableau, to do reporting, to generate reports and to understand that data. I think you're correct. There will be many verticals, like if we take the pharmaceutical or medical industries, you need specific competences. Yes. And the data will look very different.
There will be companies for this area, create these models.
And I think the other point that's very important is that the data we use for machine learning is more varied than you have for data warehouses. So we do have the data warehouse data, which is tabular data. So it's in tables in our database. But if you're going to do machine learning for medicine or for pharmaceuticals, you're probably working with files, very large images, maybe scan data. Similarly, if you're working with self-driving vehicles, you're working with image data, probably, or LiDAR data. And if you're working with audio data because you're trying to, understand what people are saying in a conversation, you're working with files again. So there's a more varied set of data sources for AI and machine learning than you would have for the traditional enterprise data, which you find in the data warehouse. So what we do see right now is that some of the data science platforms are actually, niching in. And we say this one is really good for tabular data. This one is really good for, for image data. There's some, in particular, there's a big challenge with creating training data, so labeling your data. So if you're trying to build a self-driving vehicle and you say, well, we have 1 million hours of driver footage, you still need to make sure that for all of that footage, You have annotations of what's in the scene. Where are the markings on the road? You know, were there peoples or other vehicles in the scene? You need humans to do that.
Still?
Yeah, and there's farms of people, tens of thousands of people work globally, not in high expensive areas, but often in countries like Bangladesh, Kenya, India. And there are companies that support them, that provide software to help them more easily label that data. And there are companies who will help you create label data. And because ultimately it's still mostly supervised machine learning that's being used to power a lot of the AI. We do see some work in unsupervised machine learning. We're working in the area of anomaly detection. So you don't need label data necessarily, but you see, you don't, in principle, if you're solving a problem like fraud, so I don't need label data, I just need to know that this data is not fraudulent. Okay, well, that's kind of labeled, isn't it, in a sense? But with that, then you can then train unsupervised machine learning models to do, things like generative adversarial networks or autoencoders can help predict if some new data that arrives is anomalous with respect to the data that you trained it on. So the non-fraudulent data, you get a new transaction in, a financial transaction, say, well, it looks a bit fraudulent compared to what I've seen before.
So if I ask you something a little bit more technical, I guess it's not business, but what do you think about this new area coming in, which is this graph neural network?
Graph neural, yeah. I mean, we've actually done a bit of work in this space.
Yeah, I see.
So there has been a recent trend towards storing data which has graph-like structures. So you can imagine Facebook, of course, where you have your friends and your friends of friends, and LinkedIn. That data doesn't fit very well into the relational model, the tabular model. It fits better into a graph model, where if I want to find your friends of your friends, instead of doing lots of joins on tables, it's if you have a native graph database to help find that, your friends of friends, it will be much more efficient. So if your data is stored in this graph format, and you can query it in the graph format, you can say, show me the neighbors of this particular node. You might want to say, well, are there features in this graph that are useful for machine learning? I can give an example. So if you look at the area of money laundering, so the people who do money laundering, they know that the existing systems have static rules. And they say, okay, if the money is greater than $10,000 and goes to this country that is a bit more suspect, and if this person has sent the money more than 10 times, they're static rules. And then the people who engage in money laundering know how to get around them. So there's techniques like things called smurfing, and you can have one classical pattern is that you would get, for example, with Swish, you would get a lot of young people to swish money to a central account. You say, look, I'll give you 5 crowns if you swish 200 crowns to this person. And the kids will do it because it's no big deal. And that person collects all of this money, and it gets under the static rules. Static rules can't find it. So in this case, we have, however, a suspicious graph of money flows.
So it's a subgraph, you mean?
Yeah, well, it could be a multi-hop graph, right?
Yeah.
So then, if we're going to do AI, we need to predict these patterns. That's what AI is. It's pattern matching, right? We're going to match patterns. So how do we take a snapshot of that graph over a period of time? So let's say, over a week, how much money flowed into this particular node or individual, and from what locations? How do we get that and turn it into a numerical representation that we can train a model on? And also we need to make predictions. So I also need the numerical representation to make a prediction with. And that's where graph kind of neural networks comes in. We can take a snapshot of the graph over a period of time, maybe a day, maybe a week, maybe an hour even. And we can convert it into what we call an embedding. So they're called graph embeddings. So there's many different techniques for creating these graph embeddings. You could, for example, take a program that would start at a node and do random walks around it and sample all the nodes that are there. And then it'll take that walk that was generated and convert it into an embedding, which is really just a fixed number, an array of floating point numbers. So you might have 100, 200 floating point numbers. It's a point in a 200, in n-dimensional space where n is 200, it's a point in that space. And with that, you can basically say, well, this particular one was money laundering. This particular person was engaged in money laundering. So now we have a training sample that says this is money laundering. And if we do anomaly detection, we can have lots of examples say, well, this is not money laundering. So now you can train your model to predict, based on this graph property of the graph, if a particular transaction is suspected of money laundering or not. And it is quite sophisticated, but it's really hard for people who engage in money laundering to find schemes that go around that pattern detection, because those patterns they've been using for years, and machine learning can find them. So we have a similar customer who's doing network intrusion detection. Packets come into a network. Each individual packet has not much information. It has a source IP, a destination IP. We need history, we need context. We need to augment them to be able to make a prediction if this is an intrusion or not. So the feature store does that. We collect all the traffic flows from different locations, different IP addresses. We compute counts over how many times packets have come from different IP addresses over periods of time. And then we can quickly identify with pattern matching, if a particular flow of traffic is suspected of being an intrusion or not. And this is kind of the back to the real-time machine learning story, where we can change what was previously a static lookup table, both for the money laundering and also for the network intrusion detection. That was just this static pattern matching in a table. See if a rule fires, or then we suspect, and changing that to a system that learns patterns and can take then decisions in real time, because we're going to feed it with real-time data. Because there's no good having an intrusion detection system that works on 10-minute-old or 20-minute-old data.
No, absolutely.
Yeah,
it's much more dynamic.
So I will ask you more a personal question, which is actually, I want you, so this is personal. What was the drive that make you, as an academic, just start a company with all the troubles that you can go through? Yeah. What drives you?
I think, in this case, I'm a believer in it's nurture or nature. I think this one is more nurture. Like the environment I started my PhD in was in a research group where my supervisor, Vinny Cowell, he was the first CTO of a company called Iona Technologies.
I see.
They were worth maybe 5 billion or 10 billion at the height in '99, and all of that group had left to start this company and had been wildly successful. And then throughout my PhD, and as I worked as a lecturer in Trinity College Dublin, there were just companies coming up left, right, and centre. So this incredible entrepreneurial environment, and like I mentioned, one of my students who worked with me a couple of years, Kieran Lee, started a company called Intercom, and they're worth billions now. And so I've seen this,
So you're in an environment where...
Yeah, and I came here, honestly, to Rice and KTH, and I was a bit disappointed, right? I didn't see that here. I didn't see it here. I see it now. It has changed in the last 10 years. It's changed a lot in the last 10 years, but over 10 years ago, it wasn't really here. Now, the other part of it is, as a researcher, how do you get ahead, right? So you can, as a researcher, you can look at the papers at the top conferences and guide your research around the trends that you see. You can do an analysis and say, well, this is an emerging area. I'm going to do some work in here, and I'm going to make a small change to it. You won't start a company if you do your career like that. Yes. You may get lots of papers at top conferences and have a very successful academic career, but you won't build a company around it. So when I came to Sweden, I started working at MySQL, and I worked with Mikael Ronström on this open source database called MySQL Cluster, and I saw huge potential in it. I said, this is incredible. I'm gonna solve some difficult distributed systems problem with this database, but it took a long time. I think I started at 6, and I was 2005 at MySQL 2007. And then it was really 2011 when I started doing something. We said, okay, I saw this file system, the Hadoop file system. I said, well, let's rebuild it with MySQL Cluster. And we did a project with
scale it up, basically.
Yeah, to try and see if we could scale it, the metadata. And then I got a couple of master students who work on it, and it kept getting better. And then I got research money, and we started building with Salman and Mahmoud, who were co-founders. And Saif had some very large projects, and we brought more people in. But the goal was that it was build a production system from day one. So we didn't just build everything from scratch. We had this great kind of starting point, which was a production code base, the Hadoop file system, that we just ripped out, but we still had to pass all the tests. It still has thousands of unit tests that you still have to make. So you're building production software from day one in research, but it's then higher risk, because if you're building systems research, it's going to take a few years before you get a publication or anything. Now, that worked out well, because we ended up getting papers in top conferences like Usenix Fast, and we won the IEEE Scale Prize for that. But that's never guaranteed. It's never guaranteed, and it's high risk for your career. But on the other hand, the payoff can be that you've now got a production system that you can build a company around. And I think that was always the goal. But if it didn't work out, you got some nice papers, and then you go on to the next thing. So it worked out this time, and then it took on a bit of a life of its own. And there were 11 of us when we started the company, so it's quite a lot of people, each with their own set of unique skills. And then I think once the thing takes on a life of its own, then you're just kind of guiding little bits here and there in the ship. Yeah, I mean, I think as a academic, maybe most people don't think, I want to start a company. It could be a nice byproduct, but I don't really want to do it myself. But if you've been building the whole thing, and I wrote a lot of code, and and there's no one who's going to take it on for you. Often people think, well, I'd love if someone else comes in and does the whole thing for me. As an academic, say it'd be great if I got this business guy and some tech person girl, and she pushed that and he pushed that, and then I can just take a back seat and I'm happy. But that's kind of wishful thinking at some level. If you really want to succeed, you kind of have to push it through yourself, I think, a lot of times. I'm kind of hands-on person, and there's a lot you have to learn if you want to start a company. It's a learning process. It's not. I mean, CEO is not a dream job, right? You're not just doing strategy all day. You're fixing the smallest little things, right? You're kind of the buck stops with you. So any problems that don't get resolved end up with you. But on the other hand, it's really exciting to be a European Swedish company who are really pushing out the state of the art in data for AI. And I think the talent base we have here will get there. We have challenges in terms of people are seeing that this is now a huge opportunity, and the capital is flowing in massively into this space. And
in Sweden,
I don't think so much in Sweden, but I mean globally.
Okay.
That it's a Wild West. Everyone's going to go crazy, and I don't think we have the experience in Sweden to kind of say, well, we'll always win these kind of battles. But I think in our case, we have a great chance of coming out of the end as one of the leading players. Because like many spaces, right now we have this, kind of Cambriatic explosion of companies in AI, but in 10 years' time, I won't say that a big meteor is going to come, but there's going to be huge consolidation, and nobody's going to buy 10 platforms to put AI in production. They'll just want to have something that helps them all along the way. And we really, we have ambitions to be. I don't do this to have the company acquired or whatever. I think Europe really needs leadership in this space, tech leadership. And we want to be one of the companies that can help provide that.
Great.